This is Geometry, Unit 8, Day 6, talking about vocabulary of our circles. We're first going to start out with what actually a circle is. A circle is a set of all points equidistant from the same point. Which is called the center. So our diagram would be a circle, and we would put a dot in the middle. A radius it's a segment from the center of a circle to the edge of the same circle. So, if we had a circle, which isn't the main important part, so I'm going to make it dashed, the radius would go from the center to the edge, and that would be our R value. Now, this is a new one for us this year. This is called a chord, not a chord, a chord. A segment connecting 2 points on the circle. So again, we could have a circle. That's not the important part, so I'm going to make that dashed. A chord has 2 points on the circle, and we connect those, making a segment between them. Maybe your center would be here. It would be in the middle of the circle. A chord does not have to touch it. It can touch the center. It can go right through the center, and we'll call that something different. But a chord has to touch 2 points on the edge of the circle, and that makes a chord. A diameter, it's a special type of chord. So we call it a chord that contains the center point. So if you have a circle, not the important part, so I'm going to make it dashed, we have a center point, and this chord is going to go across our circle, but it's going to include the center point. So that's going to be the diameter. The diameter is 2 radiuses. A tangent. Now, we've talked about tangent in SOHCAHTOA, but this is a little bit different. It's a line intersecting a circle at exactly 1 point. So if it's a line, that means it goes forever in both directions. How could it possibly touch a circle in only 1 point? So we'll make our circle. Our circle will have a center, but that's not very important in this case. there'll be a line that touches that circle in exactly 1 point. That means it's kind of like the circle is sitting against the line. It's only touching in one spot. A secant is a line that contains a chord. So in other words, it's a line that intersects a circle at 2 points. So what that's going to look like is our circle. I'll make it dash because that's not the important part on this definition. But it's a line that goes through the circle, not just a segment, but a line. So it has arrows at both sides, but it contains a chord. Where a tangent only touches at exactly one spot, a chord has to touch it, a secant has to touch at 2 spots. Because if it's going to contain the chord, it's touching at 2 spots. Now, on the other side, we're going to try to identify where these all are at. So looking at AB, looking at BC, letter A, we're looking at segment BC, so we know it's a segment. B to C, it only goes to the center point to the edge of the circle, so we know that that's going to be, what do you think? A radius. Now we're going to have a line, because it has the arrows on either end, of AE, or EA. So we have to find the E, we have to find the A. It's a line that goes all the way through. Notice that it touches 2 points along that path going into the circle. So we know that that's going to be a secant. DE. DE is also a line, and it's going to touch the edge of the circle at exactly 1 point. So that's going to be a tangent. Notice that DE goes right through here, and it's touching the circle at exactly 1 point. FA, that's a segment. F to A, it's touching the circle at 2 points, but it doesn't have an arrow, so it's not a secant. It's just a chord. It doesn't go through the center, so we know that that's not a diameter. But AB touches the circle at 2 spots, and it contains the center, so that's the diameter. Okay, we're going to try that again. We're going to match the notation. D. D. Let's flip back to our other page. So over here, we're going to have what's called point of tangency. So a line touches a circle, and this special point is called the point of tangency. What else is kind of cool about a point of tangency is the radius. Listen to this carefully. The radius that touches it will be perpendicular. It will form a right angle. The radius will touch this point of tangency, and it'll make a right angle with the tangent line. So if you notice, point D is 90 degrees. It's part of this line that's touching it in exactly one point. So that's going to be the point of tangency. That was kind of a tricky one. Segment FH. FH is touching the circle at exactly one spot. It's touching a different circle at exactly one spot also. But it's touching a circle at exactly one spot. So that's going to be considered a tangent. But because it has a circle on either side of it, has one on this left side and one on the right side, it's called an internal tangent. It's common because it has two circles connected to it. CD, C to D, we should all know what that one is. That's a radius. AB. That's a chord. C. That's called the center of our circle. AD. AD is a chord. It goes from one side of a circle to the other side of the circle, but it also contains the center, remember, so it has to be a diameter. AB, line AB, touches the circle at exactly 2 points. So that's called a secant. And then this line, DE, it's touching a circle. It's also touching another circle, so it's common, but it's considered an external tangent because the line is on the outside of both lines, or both circles, not in between. That would be internal. This is external because it's outside. Both circles are on the same side of the line. Okay, for this next part down here, you might not have a compass with you, but you can just draw it by freehand. You can bring in your compass if you have it. If you don't, that's fine. We would make a circle. Have our center. And that center, it says, is going to be point P. We're going to draw a radius. The end point of the radius on the circle is point T. Now we're going to draw a line TR. It's a line. It has arrows going in both directions. So it's only going to touch at one spot. You need to be careful that you don't draw it like so, where it might touch the circle at two spots. You want to try to truly only touch it at one spot. If you're drawing it freehand, you just want to do the best you can at keeping it straight. If you have a straight edge you can use, that'll be good too. Then, now it says to call this TR. So there's got to be another point on this line with R. Now we're going to use a protractor, and we're going to look at this angle PTR, and we're going to see how well we did. So we're going to bring in our protractor. We're going to put the cross of it right at the point of tangency. We're going to run the line that's on the protractor with the radius, and looking to see where it comes up. That's just about 90. It looks like maybe I drew it just a tad off, but 90 degrees. So we can put a 90-degree marker on there to show that it's a right angle. What is the measurement? The measurement of angle PTR equals 90 degrees. If you drew it perfect, it's going to be exactly 90. And what's this relationship about PT and line TR? They are perpendicular. That would be PT is perpendicular with TR. Segment PT and line TR are perpendicular. So looking on page 13, we see our theorem that says that exact thing. In a plane, that means on a flat surface, a line that is tangent to a circle if and only if it is perpendicular to the radius. It has to be perpendicular to the radius. So we can come down here, and what we're looking for is we're checking to see is ST, that could be a segment or it could be a line, but it is touching the circle at exactly one point. Is ST a tangent? Okay, don't get confused that it's not a line. You could pretend that it goes on forever in both directions, but it's considered tangent if it touches at one spot and is 90 degrees. So, if it's 90 degrees, then this should be a right triangle. And if it's a right triangle, then we can try Pythagorean Theorem to it. RS is a radius, and that's 12. So we know this side is also 12. Don't call this side 7. Only the extra part is 7. So now we have 12 plus 7. 12 plus 7, which equals 19. So what we're going to try, we're going to see is 19, is it going to be equal to, is it going to be greater than or less than? Let's find out. 19 squared, 12 squared, plus 16 squared. If that is your right angle, then the 19 would have to be your hypotenuse. So hypotenuse squared, and leg squared. So we look at 19 squared, and we're going to get 361. And we're comparing that, that's the unknown, to 144 and to 256. So when we add these two together, they are not equal to 400. So ST is not perpendicular to RS, because it did not form a right triangle. It did not make the Pythagorean theorem true. They would both have to be 361. So let's try this one. So this time they tell us that the 26 is going all the way across. It's the longest side. ST, that's the question. Is it tangent? Is it perpendicular to RS is the big question. So if it's going to be perpendicular, then we should be able to do c squared and compare that to a squared plus b squared, where our c squared is going to be 26 squared. We'll compare that with our 10 squared and 24 squared. 26 squared is 676. 100 is 10 squared. 576. And as you would suspect, 676 does equal 676. So ST is perpendicular to RS. So now we know that TS is a tangent. It would be considered a tangent segment because it does not go forever in both directions. So for example number 4, in the diagram, B is the point of tangency. So we know, since it's a point of tangency, we know for a fact that it is touching at exactly one point. We need to figure out what the radius of our circle would be. So 77 is this long leg. 49 is the part that it sticks out, but it is not the radius. So this could be a little tricky. So let's notice what's going to happen. If this is the point of tangency, we're going to take the r and the extra 49. We're going to square that. And then we're going to equal that, because that's your c squared. A squared plus b squared. Now, when we square r plus 49, that's a new thing for us in geometry class at least. You may have done this a little bit in algebra, but not yet in geometry. R plus 49, we're going to put that in parentheses once. We're going to put that in parentheses a second time. Because it's being squared, that means it multiplies itself. R squared plus 77 squared. Now, when you multiply what's called two binomials, you do something called FOIL, where the F stands for the front. So we multiply the front and get R squared. Then we multiply O, which is outer. We multiply the outside part, which is 49R. We're going to multiply the inside part, which is also 49R. And then we're going to multiply the 49 times 49 and get a big number, 2,401. Then we have R squared. And when you square 77, you get 5,929. So now we're going to collect like terms. We're going to subtract the r squared with the r squared. That crosses them out completely. That helps a lot. These two put together are going to add up to 98. And we're going to subtract across the 2,401. Subtract across 2,401. So that's going to give us 98R equals 3,528. What would we do next? We want to figure out what the radius is. We need to get to R by itself. So we're going to divide by 98. So R equals 36. Let's try that again on this side. Here we notice our long side, because that's across from the 90. That's going to be r plus 9 squared, that's our hypotenuse, equals leg squared plus the leg squared. So when you have something that's being squared, that's telling you to write it 2 times. These are called binomials because they're a value that's adding, or it's adding together. It would be fine if it was adding or subtracting, but in these cases it'll always be adding. Then we're going to do FOIL, which is the front, the outer, the inner, and the last. That's r squared plus 225. Now we're going to subtract the r squareds. That's going to help out a lot. We'll move over the 81. And that's going to give us 144 on this side. The 9 and 9 give us 18. They're adding, remember, not multiplying, but they're adding. So we're going to divide by 18 to get the r by itself. So find the radius, and the radius would be 8. Okay, this last example, number 5. A dirt bike chain, this is the chain of a bike, fits tightly around 2 gears. The circles are considered the gears. The chain and the gears form a figure like this one here to the right. Find the distance between the centers. This is what we're trying to find. Okay, this is going to be a little tricky for us to come up with. So there is more than one way for us to do this, but so far we don't have a right triangle going on. We could draw in the diagonal this way, and then you'd have a right triangle, but that's not the distance we're looking for. We're looking for that distance. So we see that this is 2.4 on the way down. If I was to draw in a new line that was parallel to this one, then this portion here would also be 2.4. So then that would leave this you would have a 90-degree angle. So if that's 2.4 and this is 9.3, what little bit is left over? 9.3 is the whole thing minus the 2.4. That leaves us with a remainder of 6.9. So this is 6.9. This part of our triangle. We're looking at this triangle now. That's right here. So 6.9. This slanted part here is what we don't know what it is. That's our x, that's our hypotenuse. This length all the way down is the 26.5. So now we're just going to do Pythagorean Theorem to figure that out. So we know that we use c squared equals a squared plus b squared. Could also call that hypotenuse squared equals leg squared plus leg squared. The c squared is our x, because that's our hypotenuse. It's across from the 90. The a is the 6.9 squared. The b is the 26.5 squared. So when you square 6.9, you get 4761. And when you square 26.5, you get 702.25. So we'll add those two together, and we'll get 749.86. Now we have x squared. If x squared equals 749, what do we need to do to find out what x is? Some of you had troubles with this on your quiz. We have to take the square root. And that's going to become approximately 27.38. And these are inches still. So the distance between the two center circles, once we turn this into a right triangle, we are able to use Pythagorean Theorem to figure out 27.38.